Okay, so on the Discord channel, I think there was questions around recording not being accessible because it is sitting behind the firewall in my personal OneDrive. So an effort is being made. We are trying to come up with a process where we post all these recordings on YouTube, and then I will share the. It will be an unlisted link, but I will share the link on Discord channel, or every meeting I'll share the link so that you have access to all the previous recording. So bear with us. It has been a month, I understand, but few more days and I will have them up and running. So then that will become a process that moving forward, we will record and then we'll publish it on YouTube. So it is not hidden behind, it is not barred behind NVIDIA firewall. Okay. Is there another question? Yes, me too. Jim, that was really good. Your video was really good. I went through the whole video and I enjoyed it as well.
Hello, everybody.
Hello. Okay, I think we can get started. So this is here. Maybe give 1 more minute. We have a lot of people, but people are still joining. Let me address this question. Mitesh, if you can please let us know if there is an update for Isaac Ross from Humble to Jazzy. Forum said Jazzy was coming in May. Rafaelo, do you have any indication of this, Rafaelo or Chitoku?
From my side, no, I don't have update right now.
Okay. Neither. Okay. Amazon 114. I don't know your real name, so I'm addressing by your alias. I will get that answer back to you. Are you on the Discord channel as well?
Yeah, I'm one of the people who have started and one of the admins.
Okay. All right. Perfect. So I will get that answer for you, and I'll post it there.
Okay.
Yeah. All right. Likewise. All right. Let's get started. So we have two talks this morning. One of them will be from Chitoku, who will walk us through Jetson Thor. Bill, can I mute you? Okay, thank you. So Chitoku will share things on Jetson Thor, which we launched on 25th of August. A lot of you have seen it, I'm presuming. But Chitoku might have something sitting on his desk that he can raise and show it. But he will be talking about Jetson Thor, and then Kabilan, who is one of our community members from India. He has created a really good demo with hardware-in-loop setup. Using, I think, Quen 32 billion parameter model. So he will be showcasing his work as well. I think he's going to show a live demo, but regardless, he's going to showcase his work. I think the LinkedIn post is already live, which has received a lot of likes already. So with that, I'll pass it on to Chitoku. Chitoku, go ahead.
Yeah. Can you hear me well?
Yes.
Let me share my screen. Doing that. I'm going to be now. Give me a moment. Setting up my presentation mode. Here you go. All right. So you see my screen? Good. All right. Well, what I'm going to present to you today is, of course, Jetson Thor and Jetson's AGX Thor developer kit that we just launched on August 25th, just Nitesh said. So there are many things that we'd like to cover. But to start with, let me introduce the overall picture first. NVIDIA believes that we need three type of computers when it comes to especially tackling the physical AI or anything physical. The first computer on the left-hand side is a big data center. Those are all the big GPU computer or even clusters that takes care of training a big model or even fine-tuning the foundation model. This is to eventually give us the fine-tuned model that is to be deployed to the edge, but it takes a very big task of the model. What goes hand in hand, especially in the context of the physical AI, is a simulator computer on the right. So this is what we call second computer or OVX. So this is basically a simulator that generates all the data to represent the actual physical world data set. So this is going to be mashed up with the real world physical data set that we take from the physical world and fit it into the big training machine on the left-hand side, first computer. So they work hand in hand. This allow often people go back and forth to eventually create a fine-tuned model that is suitable to be deployed at the edge. So eventually, what comes out from those two machines up there is the model to be deployed on the edge computer, which is the third computer, our Jetson. So Jetson sits on this third computer here, but as you see, this work in unison with all the other computer. So that's where our Jetson sits in this three computer problem paradigm. Now, we believe that real-time reasoning is the key to unlock the physical AI problems. So if we don't have the edge computer, everything would be fed to the cloud data center and then that would be processed and then eventually come back. But there are many applications that cannot be satisfied with that pipeline because of the inherent latency, bandwidth required, sometimes a security reason. Humanoid is a great example, right? Just like the auto or the automotive computer, it requires to be on the vehicle. It would be hard to imagine that gets processed in the cloud and steer the vehicle on the road. Eventually humanoid is to interact with us who are really latency responsible being. So we want that to have a capability of being able to respond in real time or very short latency. It requires multimodal capability as well. It should process not only the textual information, but also the vision. We want to share the same world perceptions with a robot. So it would need to have not only the LLM, but VLM or even VLA model. That is just for the humanoid that we see a vast array of applications that require the edge capability. And some of them are listed here. I will skip ahead and really get into the meat of today's topic. So Jetson Thor is our next generation of Jetson lineup. When we say Jetson Thor, it actually refers to this module that's depicted in this bare form on the picture on the right. So it features all the great spec like we always talk about. But one of the most important thing is it comes with a Blackwell architecture of the GPU. This is same as what you see on the GB100 or any latest desktop or data center GPU. It comes with all the great feature like FP4 support. So, sorry. So we can take advantage of all the features that is now being supported on many of the inference framework of LLM, VLM. You can see other like great feature like interfaces and what comes with this SOAR. So to bring the capability, all the goodness of the SoC, the module, what we provide is the developer kit, which is what's sitting on the back of this module. So through the developer kit, we unlock the developer to have access to do great things on this SOAR module. This will be eventually be integrated into our customers' humanoid or whatever the application. And we have actually two kinds of Jetson SOAR module. What comes in the developer kit is T5000. So what you see on the left. And we will come out with slightly low performance but optimized module T4000 in October next month. Those are going to be supported on our developer kit carrier board, so people will have immediate access to it when they are available. So what I have is here, the Jetson AGX SOAR developer kit. I'm not sure if you can see, those are the interface. You can look at my camera feed or this picture. It shows all the carrier board IO, and more sort of gimmick here is that there is actually a debug USB, which is kind of handy if you are like really managing this in a sort of like a data center environment. But usually you get to do most of what you're interested in doing through this IO. What's interesting is that now it even comes with a QSFP28 Ethernet or fiber socket. So it can even like go to your 25 gigabit BPS Ethernet switch. There's a big grill that dissipates close to 140 watt coming out from the SOAR module. You can actually feel sort of like a hot air coming off when you're running a benchmark on this. It's a nice hot breeze coming off from this. It's not like noisy or anything, but yeah, there is a gorgeous sort of heat management solution already attached on developer kit. Anyway, you can marvel this later. I just took this out from our sort of like build farm. So I will put this back immediately after this call. This shows like one of the greatness of having or running things on Jetson SOAR. When we talk about the LLM, we can expect two things greatly improved, especially by the performance of the SOAR. First time to token is going to be reduced, and of course the sheer throughput is going to be shortened, or throughput is going to be increased. So that's what we are trying to depict on this diagram. It's a huge sort of increase from Orin. The integral of those two metrics is what we really want to promote. Now I would like to go into the software side of the this product. Jetson, well, Jetpack 7 came with the introduction of Jetson AGX developer kit. Jetpack 7 for now is only for Jetson SOAR. This is not available for Orin yet. At the high level, well, yes, it supports all those hardware features that comes with Jetson Soar or Blackwell GPU. But we, for the distro and the kernel or the base OS, as a part of BSP, we decided to go up to 2404. This sort of like impact the discussion we just had earlier, right? What's the support for the latest ROS? So it's great that our BSP is now on the latest of the Ubuntu distribution. Comes with all the security features. Some of them you'd like really care when you like go into the QSP or the UFI level, sort of like a BIOS feature of Jetson. Camera continue to be a very important peripheral for Jetson. Many of our product customers would have some kind of camera solution associated with Jetson. And in fact, we are introducing what we call HSB, Holoscan Sensor Bridge sort of protocol, new camera interface to Jetson that's available not only for this, but for ORIN. So I will try to cover that later. The display, when we say up to 4 HDMI or 4 times DP, this is talking about the module capability. So one can actually produce a carrier board that takes full advantage of the SOAR SoC. All right. So this is a roadmap that we want to have people sort of be aware. In August, like I said, we are going to introduce T4000 module. And with that, we are going to introduce Jetpack 7.1. This is the time we are going to introduce some of the minor update to our BSP as well. But the main feature added is the support of T4000. We should be able to talk more about what exact feature going to be available as a part of Jetpack 7.1. Or it's more like a Linux for Tegra or L40 or Jetson Linux, Rail 38.3. So that's what we are seeing for SOAR. And we will have a different announcement of the Jetpack release for ORIN. So for now, let's just focus on Jetson SOAR. And I'm happy to take a question later on this chat or on our forum or on our Discord about the ORIN support. All right. So CUDA 13. For now, what I would like to really stress is SBA support, SBSA, server-based system architecture adapted on SOAR. With the introduction of the new type of GPU driver, or actually same architecture GPU driver as a desktop counterpart, we now finally make the Jetson sort of work the same as other ARM64 computer, server computer that can put GPU on it. What's great about this is we already have CUDA toolkit released for SBSA. So Jetson is going to be compatible with other ARM-based systems. That means we can just like install the SBSA version of the CUDA toolkit. We can take advantage of all the tools that made available for SBSA. And then when you think about the sort of like cross compilation sort of paradigm, some wild idea is that you don't even like now cross compile. You can actually compile on the ARM-based server and then bring that to Jetson. I'd like to spend more time on SBSA later. I think it even deserves one full webinar on this. So let me cover this but later, but this is a big deal. I want to stress. All right, so how to get started? That like dramatically easy on this. What it is we finally introduced sort of USB installation media. You can download the ISO image from NVIDIA developer or NVIDIA download site. Yes, you can just like flash it on USB using any of your computer, not the Ubuntu PC, not the giant desktop PC, but you can use your MacBook, Windows laptop. Maybe you can use Chrome. I'm actually not sure, but any client PC would do, right? I mean, just like trying to create the Ubuntu installation media for your laptop when you are to install Ubuntu. So we finally introduced this feature, got rid of the necessity of the Ubuntu host PC, no need of host PC. That's a great deal. So what we are doing is we came out with this new quick start guide that's centered around this Jetson ISO USB installation disk process. This is being laid out in easy step, 5 steps to follow. So people should. I'm confident people will enjoy this new way of installing the Jetson BSP. This actually takes like 12 minutes, so it's much faster than using a Ubuntu PC, and it's pretty reliable. Another thing that we are introducing or like explaining on this online user guide is different way of installing BSP. Using SDK manager to install BSP, Jetson Linux, is still supported. But please know that Jetson ISO is sort of like a parallel alternative to that and actually recommended way. So yeah, please, if you're interested in or first time going into like this, please check out this documentation to get a sense of what it's really doing and then the difference between other approach. Jetson AI Lab is another thing we are like really concentrating and actively working on right now. You may, and my partner in crime here in making Jetson AI Lab, and of course the Jetson container was Dusty. So we all love and respect. He stepped down, decided to leave NVIDIA, so he's no longer with us. But NVIDIA is committed to provide a good care of what he left, and we are actively supporting it. With the help of the community, we are working really hard to bring the Jetson source support on Jetson containers, as well as introducing SOAR tutorials or upgrading the existing tutorials to cover SOAR. So those are the things that we are actively working. We are not abandoning those great projects. They are going to thrive, and then we'll have a much bigger role. It is now, Jetson Container especially is now a very integral part of Jetson product. So we are like trying to spend more efforts and resource on this. So some of the migration work is underway. We are, as you may be aware, we are moving the server of Jetson PyPy, APT server, and eventually where the built container image being hosted is going to be moved to other location, most likely just a GitHub container registry under NVIDIA AI IoT existing organization. So yes, so those are going to be supported. We cannot like really give out the exact timeline when we are going to complete the whole migration, but it shouldn't take any longer than going to the end of the year. So that's the last timeline we are working towards. And then yes, with the team we are working very hard right now. This is one of the examples that we introduced for centric tutorial, Orama. We are actually working with the Orama company as well, and they are working hard to bring the native support, just like how they did for Jetpack 6. But they are now looking at sort of like a dual CUDA version support for their installer, so it's taking a little longer time. Until then, what we are enabling people with is a dedicated SOAR Jetson, it's not even Jetson container, a dedicated container image. So people can just follow this instruction, Docker pull the image from our, GitHub container registry, and people should be able to do exactly this. This is the easiest way to test the GPT OSS 20 billion. Not only 20 billion, that you can actually do 120 billion, 120 billion. So that's something. It's taking full advantage of the 128 gigabyte VRAM of Jetson Thor. Another great demo that we showcased is this Groot N1 hardware in the loop demo. The best way for you to see is probably to go see this Sakizat. He just uploaded his new sort of article covering this demo. So he got to replicate this demo. Jetson, the layout is a PC with some beefy GPU is running Isaac Sim, simulating the whole environment with the robot inside. But we take out sort of like the brain of the robot onto Thor and let them work in unison. The idea is that you are actually using the sort of raw brain of the robot in the physical world, but it's living in a matrix. It's hooked up to a matrix world being simulated by NVIDIA GPU in Isaac Sim. But like the robot brain doesn't know it's actually in matrix. So it's like diligently trying to perform whatever the task it tried to do. At the end, whatever that's rendered on the simulator is get fed to the robot brain, and this in turn going to act on it. So that's the loop it's forming, hardware in the loop, and we demonstrated this paradigm. It works really great, especially when it comes to the situation where we need to validate a fine-tuned model. We in fact had like this very problem or dilemma of validating the model. If you just like calculate the cosine similarity of the eventual fine-tuned model, it looks fine. But when we actually run in the simulator, it like the robot acted wild. We can catch that before even deploying to the physical world and really getting the robot to go berserk, right? So yeah, we by ourselves felt the very benefit of using this paradigm. So we are happy that we are sort of showcasing this as a part of Jetson Thor demo. All right, so that's pretty much it from my side for this presentation. I see there are many comments that came in, so let me try to spend some time after this.
Yeah, maybe we can address few. There are simple ones. So
sure.
One of them is, what is the maximum power usage?
Maximum power usage of this. So the Thor module goes up to 140 watt. That's as much as this heatsink can take. However, you can actually supply more power through the new power connector, microfit connector, because you may want to spend more power on some of the peripherals. So think of that as sort of like a headroom. But that's like the power budget.
Okay, there's one. Another question is still no hardware TPM.
Hardware TPM.
Yeah, I'm not sure what that means. Andy, can you clarify your question?
Yeah. Hi guys. So TPM is a trusted platform module. Normally is used for encryption on board. I noticed that you mentioned firmware. I wanted to make sure that because this is a specific, we work in defense industry. We need to make sure that basically we have onboard encryption. For everything. Just wanted to know if it's added.
Yes, I saw your question. Thank you for clarifying. I'm pretty sure hardware TPM is available, just like the other or previous platform. I would recommend you to go into the L4 Jetson Linux developer guide. It should talk about how to use or configure the TPM for security features. That comes crucial. I will post a link to the documentation on the relevant page later.
Okay, thank you.
One more question is, what happened to GPIO?
What happened to the GPIO? Okay. Yes, thank you for bringing that up. You might have seen you might have noticed that we took out the familiar 2x20 or Raspberry Pi inspired GPIO header from this. Well, frankly, because we didn't have enough land space on our carrier board. However, it's not there like completely removed from an SoC or the SoC interface. One can still find a carrier board that takes advantage of the GPIO. So through such carrier board, GPIO is still usable. We should be able to show what carrier board actually pulls the GPIO interface in the future. That would come from our partner.
Okay. Thanks for that. We'll take two more questions. I'll address one question broadly. Can DGX Spark run Isaac Sim? So stay tuned for that. DGX Spark has not been released yet. We will be experimenting that internally, and we'll relay that information in upcoming calls once we have validated all those things. So stay tuned for any questions related to DGX Spark. Another question is, can you run Isaac Sim on Thor?
So that actually is the same question, right? Isaac Sim on Spark, and their internal build, but I don't think I'm the official person to talk about the future release plan of the Isaac Sim.
Okay, got it. So Martin will get back to you with that answer. And last question I'll take before we move to another one is, when will you release technical reference manual for Thor? Like, it's 9,000 page long document.
Yeah, I'm happy to see another people waiting for the 7,000 page document. I need to check the status of that and then get back to you.
All right. So Martin, I'll post the questions for which we don't have answers right now. I will be posting them on Discord once we have clarity. In essence of time, I'll go ahead. Okay, one quick question. When the Drive HX developer kit will be available to buy? Let me get back to you on that. We are folks on the Jetson side of things. So let me figure out that answer for you, Naveen Kumar. In essence of time, let's move along. Keep your questions coming. If we have more time at the end of this call, we'll try to address those questions. Thanks, Chitoku. Next up is Kabilan, who is going to showcase his work using Jetson Thor, very similar to the example that Chitoku showed, but it's looking into a different area. Kabilan, I'm presuming you're on the call?
Yeah.
Okay. Yeah, feel free to share your screen. Yeah, you're audible. Go ahead.
So my screen is visible? Okay.
Yes.
Yeah, Chicago is a nice presentation of an overview of Jetson Thor and a lot of questions which I'm getting from the users. Today, the BOS event is going to happen. I just shown the Thor to the customers. They asked a lot of questions on the general purpose input-output pins. So only I put that question. Yeah. So yeah, I just made some demo using a Jetson Thor and hard on the looping, where I just simulate the drone on the Isaac Sim, and I ask a lot of questions to the drone, and it start explaining using a Q 2.5 32 billion model. So the overall technical architecture of the hardware needs intelligence. So Jetson Thor. So the Jetson Thor is get used for decision making in autonomous systems like firefighting drone, rescue, and surveillance drone operations. We can utilize Thor on those applications to make an autonomous decision purpose. So in this demo, I was using a Qn 2.5 VL 32 billion model to interact with the world and getting information out of that. So the Isaac Sim, where I just simulate some forest environment with a drone and getting a photorealistic simulation world to like the forest with the trees and some houses. So that's a demo I made it up. So natural language interaction. where the real-time query processing, the visual sign analysis using a computer vision, the VLM which I'm using, the environmental pattern recognition, and contextual understanding of VLA and VLM processing. The real-time response generation from the Jetson Thor. So the brain is getting a real time, but the entire world is in a simulation platform. In ISXM, the drone is get simulated. So all processing occur locally on the Jetson Thor. I'm not using any APIs or any other out of that. The model is get dumped on the locally the 32 billion. So ensuring the low latency and reliable operation even in a remote environment without the network connectivity. So critical applications transferring the industries. Mainly for we can focus on disaster response. So where if any fire accident happens, so there will be some firefighter drone will start understanding the situation and taking a correct decision according to the environmental factors, the disasters. And environmental monitoring, we can use it in a surveillance, ecological systems, while tracking, habit assessments, and advanced pattern recognitions in construction site and pollution resources also. The safety operations and hazard identification in industry environment, construction sites, and public spaces also. We can go ahead with these demos. So the final one, meme like dreaming a frame to the cloud, waiting on latency. On board a QVL on Jetson Thor, the real-time in ISXM. So the demo which I create looks like this. So there will be a live feed from the ISXM, and we can give the prompt information, and you can see the response using the tab. And just launch ISXM. And Thor is already get launched with a Docker container of VLLM ROS2 image. Inside that, all the app image and the essential ROS2 packages is available. And so this is the word I'm using right now. And these are the active topics. So these are the active topics from Jetson Thor in the VLLM container, ROS2 container. So there will be some publisher and subscriber node, the camera underscore image having a publisher information. Okay, and it start sharing you can see the publisher node and subscriber node is count too, and the live camera feed will be get shared to the web app, and you can give the prompt, and according to that the drone will start working and getting the information of the environment. So I have some recorded video. There's some issue with the CUDA core memory, I guess. So using a ROS middleware, transferring the data between the ISXM and the Thor, and using a same domain ID, there will be a 0 domain ID for a Thor and also for the ISXM. The both device will be get connected in the same network, same like in hard on the looping techniques. But from the camera feeds from the drone, the camera feed will get into the Thor, and Thor already using a VLLM 32 billion model inside that. And we can ask a lot of queries regarding the environment, and it start explaining those things. So this application, we can use it on rescue operation, firefighting drones, and agriculture applications also, using a physical AI. And finally, another one where I'm working with the XLE robot using a GRU 10.1 model. So right now I'm using a real robot and a simulation robot to collect the data sets to fine tune my GRU 10.1 model to deploy in the Thor and testing hard on the looping without the robots. Yeah, there's a VLM response. Yeah, that's all.
Yeah, that's great. I have a question for you. Yeah, great demo. Everyone is saying that, so indeed, great demo. The question that I have for you is, are you planning to release all this code base that you have worked on of how, if I want to use it? Okay, that would be great. When you have it, please share it with me, or please share it on the Discord channel so people can use it or capitalize on it for their own application or testing purposes. A second question I have is, so in the prompt, if you write, go and find, explore the forest to see a place that has fire, does it do tool calling as well, that it will do the operation accordingly and go into exploration mode?
That
or
I
not
need
at the
to
moment?
work on that, for like an action model. So I have
Got
the plan, but first I will launch the entire demo for this. There's an issue with the DDS, fast DDS communication. While launching ISAXIM and transferring the data between the Thor and this, there's some crashing issues going on. So once I finalize that, I will launch the container, which I already built it with that.
Got it. So I think that's a similar question from Amazon 114 as well. Are you using accelerators or optimizations to tune the vision language model? I'm presuming
So
it
right
falls
now
in the
I'm
same
using an
category.
inference for VLLM thing. So then just I calling to the ROS node locally, then it starts processing the prompt, whichever.
Okay. A follow-up to that, what he asked was Qwen2 VL series, an advanced upgrade from Qwen2 VL models, extends the capabilities of vision language understanding to include action, execution, and multi-step reasoning tasks. Okay, it's all about Qwen2 treats tasks such as UI operations, robot controls, games, and navigation as sequential decision-making problems. Also, these are features of Qwen2 VL model. Is that what you were saying? Oh, okay.
Yeah, it's the next. I think it's the next generation model. So I think it's the next generation after the Qwen vision model you're using right now.
Got it. Makes sense.
With,
Also,
with the action tool calling built in.
Got it. So then potentially it will, we don't have to worry about having the tools calling module or in the prompts. It will figure it out itself.
That's the idea. That's the whole space. Yeah, the vision language
Got
action,
it.
like run.
Sure, makes sense. Do you know when it is coming out, or is it already out?
I think the Qwen vision language one is already out. The action model is already out.
Okay. Cool. Any more questions for Kamila? Keep them coming. I have one more question. The second demo that you showed regarding the gripper where you were doing SIM to real to SIM transfer to collect your data.
Yeah.
Right? So you collect your data this way, and then you were training the GROOT model, and then deploy it and see whether the Lee robot model can do the pick and place kind of operations.
Yeah.
Okay.
The workflow is already created by the Lightwheels lab, Lee Isaac. So I take the example from that, and I start working on XLEE robot, which is a bi-manipulation techniques robot. So just I'm simulating the Isaac lab and start recording a trajectory not right now, and I'm planning to release the demo by next week, I guess, right?
Okay.
After fine-tuning the GROOT and 1.5.
Got it. Okay, any more questions for us? For Kabilan? More importantly, before we go into normal Q&A? No?
Oh, yes.
Okay. Well, thanks, Kabilan, for coming and giving a walkthrough demo. Really cool.
Thanks.
Yep, thanks for coming on. So moving to just general Q&A, if we missed any questions, or if you want to ask more questions to Chitok or Kabilan, feel free. Any other housekeeping questions, feel free to ask them as well.
Yeah, I got a bunch, but I won't ask them all at once. One of the ones is I've been building Intel RealSense on the humble Isaac Ross demo, but I was also starting to forward port and trying to see how far I could get with Jazzy. And so as I'm building things like the Intel RealSense SDK for Jetson Orin, as I'm building the ROS drivers, I'm just wondering, is there like a place for us to compile these things and then make them accessible? Because there's not like a you know, a Debian package for these specifically for the Jetson Orin, and I think being able to make it easier to access, you know, the ROS driver and access the RealSense SDK can be really helpful for people who are trying to debug and get in at the early levels. So what's, you know, is there a place that we should be trying to think about compiling these packages or put them in PyPy or have you know, go upstream from community support to, you know, something at the Jetson Lab level to store these things?
I think that's a very good question, and we should definitely look into having them accessible to rest of the folks if you are building it. Chitoko, any thoughts of how we can support this?
Yeah, I think we are getting to a very good point. But the underlying sort of problem here is, I believe, I'm assuming it's RealSense SDK not fully supporting Jetson Orin or Jetpack 6.2. We probably need to start from like really understanding what's falling short. And then we can probably come up with good idea. Yes, you know, compiling something and then trying to upstream to that is an option, or like some community-oriented contained solution in Jetson container is another option. Yeah, I'm open to it. Let's discuss. Well, first identify the issue and yeah, discuss the potential solutions.
Yeah, so just to give some context, like if you're coming to NVIDIA and you've got a Jetson device, you basically would come and then you would say, oh, okay, Isaac Ross 3 is available, which is based on Humble. You know, that's 2-3 years old right now, and they're very, very clear in the documentation, like only use this version of the firmware, only use this version of the SDK, only use this. And so it's a very brittle, in my opinion, a very brittle setup, which is fine because that's tutorials and you want tutorials to be very specific. You don't want to spend a huge number of resources debugging. But so then, you know, for me, trying to figure out how it works and trying to think about my use case, I'm just spending a lot of time building these lower level components from source, which again is fine. That's what's great about open source. So then the question is like, how do I contribute that back so that the next person who's plugging in their camera and is like, hey, I'm trying to, like in my case, I'm trying to support like a visual simultaneous location and mapping scenario with my RealSense camera. How do I make these things a little more accessible so that people can download them? And this is why I like, you know, moving to GitHub container registry, because now when we're looking at Jetson containers, right beside Jetson containers, we're going to see the container image that we can just download right away, right? Because even as powerful as Jetson containers is, just making everything a little more turnkey and community contributed just makes it that much more accessible for people to grab stuff that's, you know, somebody else has built, saves them a lot of time.
I see. So you're still working on Orin and on Ubuntu 22.
Yeah.
You're trying to maybe future-proof it in anticipation of going to 24 or Jazzy. Yeah, and then I understand. There should be a way to even have Jetson container approach and Isaac Ross team's approach some closer. So yeah, I totally understand what you're proposing. I just don't have a good answer right now, but
Okay.
would like to continue building our idea on it.
Okay.
Okay, we'll take that as an open question. Amazon 114. What is your real name?
Yeah, my real name is Kieran, and then online usually people just call me Amazon. Okay. That's fine.
Okay.
Either one I'll go for.
Okay.
Yeah, and I think it's just like, how do we think about as a community, like, we ran this PyPy server for a long time, and then so somebody, presumably Chitoku and Dusty were kind of making some things, but also some of the maintainers were thinking, okay, what do we put in our PyPy server, right? Because these are very common. We build them on Jetson. So this Python library we want compiled here. So do we just file issues, or how do we think about, like, when we want to make a contribution? And Johnny, how do we think about, hey, I put X number of hours into compiling this, or making this Python library, or building this Debian package. How the goal is not to get NVIDIA to officially support it, but just to say, hey, this worked for me. Let's get a little bit closer to sharing, these intermediate work products.
Yeah, I see. That's another great point. We should have like a traceability. So if you see any issue with anything that's put on our Jetson PyPy server, please let us know through finding a GitHub issues, or making a comment on our forum. In any way that is welcome. We want to know and want to have a good scheme for people to like really know how those are made. We are planning to make it even more clear and a more streamlined pipeline to push all those or upload those wheels to the PyPy server. So that will be the sort of ultimate solution or answers to that question. We're working towards that. In the meantime, if you see any issues or things that you want us to sort of make sure we do, please let us know.
I'm just, and also, not just from the NVIDIA, but like the community. Like, I know, Jim's always posting stuff. He's got a ton of scripts that are super useful that can save days of headbanging. And so, like, what do other people do when they build something, and then they just throw it in a GitHub repo and post it on there and hope it shows up in search?
Go ahead.
Yeah, I think we can still operate on that. If we find a better way of integrating such work, and then if Jim is willing to, then we can certainly seek a more collaborative, but community way. Of course, NVIDIA doesn't need to like step into like dictate all, right?
100%.
This is an open platform. Everybody is coming in. So we just probably just organically find a better approach. I mean, if we find one. For now, I'm happy with finding James' contribution on his own GitHub repo. If people find a better way to combine or build upon it, there can be an option. We will probably just discuss, case by case.
Okay, moving to another question. Will there be a low spec for like 16 GB, 32 GB? That's a question from Martin, and I think Clement is also interested in that question.
Yes, I totally understand. You will see that just the physical sheer size of the Jetson Thor chip. It's a giant chip, and you can actually sort of like put it on top of the, our Nano or NX class board, right? It actually exceeds the size of that. So for that reason, NVIDIA's official stance is that we are going to continue to support both Orin and Thor together. We don't have any immediate plan of releasing an NX size Thor solution.
Got it. Another question was, where did it go? Does Isaac Ross run with Jetpack 7? I have not experimented. Have you?
My understanding, Isaac Ross 3 is humble.
Will be released a new version of Isaac Ross soon for Jetpack 7.
Okay.
What is soon, like Q1 26 or is soon Q4 25?
I don't have idea, but the engineering are working on it. Just to keep you know that the engineering are working on it. I don't know when.
Okay. I'll try to get a timeline on that, Amazon, but at least we know that engineering is working on it. Thanks, Rafaelo, for adding that info. more questions. So we addressed the Isaac Ross one. Okay, someone's meeting notes just summarize the whole meeting. That's cool. Any more questions? If not, we will definitely. I think the next call is on 9th of October, if I'm not mistaken. Let me make sure. Sorry, it's on 7th or 14th. It's on 14th of October. So yeah, we'll reconvene in 4 weeks. 14th of October is the next call. Again, we are looking for speakers. If you have done some cool demo on Jetson Thor, feel free to reach out on the Discord channel. I'll be very happy to have you on board and talk about it.
Yeah, a lot of demos are loading on.
Can I just bring up one of the things? We got a couple minutes left.
Sure.
I just wanted to open up like how people are thinking about, when you're working with Jetson. I mean, obviously we're talking about Thor, so that's like a completely different ball game than the nanos. But with the demo we just saw, we're starting to see vision language models and vision language action models. And so one of the questions is, how do you take this high put data stream of images and video, and then how do you process it locally? And so one of the things that I'm excited about with Jetpack 7 is it brings us to kernel 6, and then with kernel 6, now all of a sudden we can support Wi-Fi 6, and so now you're getting up to like close to 2 gigabits of streaming over Wi-Fi. So a lot of what we've been thinking about as well, image processing is so intense, we got to do it on the Jetson locally on the robot. But now we might be moving into a world where we could actually stream high enough bandwidth video off of the device and then process at the edge, not directly, sort of like the three computers Shitoku was showing earlier. And then some of the things like we're seeing in ROS, there's a protocol Xeno, which allows you to do much more efficient ROS broadcasting of your images. That's available on Humble and community support, and then it's tier 1 in Kilted, and then also in Kilted, ROS Kilted, there's NV12, which is sort of a native pixel format, so you don't have to do as much translation on the Jetson itself. You can just pass that through for processing. So I'm just kind of wondering if anybody's got any thoughts about how they're thinking about the future of video on the device, and whether it's all going to be processed locally, or whether people are starting to think about moving it off the physical robot itself to be processed at the near, maybe like a local desktop or a local compute station.
I think that depends.
Anyone?
Yeah. I think that depends a lot on what your latency is. For most of the work I'm doing, it's not robotics, it's wearables. But like the idea of post-processing anything is not really an option, because even adding 100 milliseconds of time, if just say you could process it remotely in that amount of time, is not acceptable. So, I mean, if you have a very slow robot, then maybe it doesn't matter and it can offload it and you can send it off-site to a larger machine or something with more capabilities. But I would say that if you have a drone, or if you have a robot that moves relatively quickly or needs to respond quickly to whatever stimuli it's receiving, that even half a second or something could be detrimental to that device's operation.
Yeah, that makes sense. I just imagine without Wi-Fi 6 and 2 gigabits per second speeds, none of this was even considered. And then now all of a sudden, on the horizon, maybe Q1 2026, we'll be in a position where we can, buy a $7 Wi-Fi 6 plug, put it on our Jetson.
And again, even in those cases, you're still talking about a very controlled environment where you have Wi-Fi access to the system that you need to.
Yeah.
And that it's local, because obviously if you're transporting it to a data center or whatever else, you're adding additional latency.
Ball game. Yeah. Definitely the scenario I was thinking was local, right?
Okay.
Which is like you have a local compute station on the local network.
And I really don't know what, I haven't played with it, so I don't know what Wi-Fi 6 latency looks like. How much is the network adding to it versus how much? As we know, you do anything remote compute, that's going to take a certain amount of time to compute remotely before you even get your data back.
Yeah.
Yeah, thanks.
Yeah, I mean, one place it could be a game changer would be in telemetry and data collection type scenarios where you may not need immediate feedback, but you might want to monitor a lot of sensor points. And to your point, Kieran, you need, a local Wi-Fi edge server or something. But like you could imagine, I could see your point possibly in the situation of having a large industrial floor maybe, or even something at campus where you're spreading out things and you don't need immediate real-time processing. But I think that was your point, is to have something where it's offloaded as opposed to locally processed, ultra local. We should define what local means here.
Yeah, and even maybe what you're talking about. What if I'm using a certain amount of data for immediate processing, but maybe I'm sending it off to do some sort of batch processing that returns later, and that's not it doesn't have an immediate need. For example, if you were mapping a room or something like that, that mapping could be done, could be offloaded while your real-time responses are being done locally.
Yeah, that's exactly it, right? It's like, I don't have to build the map in 10 milliseconds. I'm happy to get the map in 500 milliseconds, so I can take my next action. And it's that trade-off of, hey, we're seeing, this emerging world of physical AI coming and becoming accessible. So what are the compute trade-offs that I need to make on the board, so that I can keep my robot moving? Maybe I can even bring one of these small Nemotron models locally on the Jetson device itself, but I've got to pay off. I've got to make a trade-off in my compute. And if I can take my image compute off, or some of my image compute off the board, go do vSLAM close by on another robot node that's not on the mobile device, then that buys me a lot of action potentially.
And to your point, I'm big on parallel processing. Anything I can offload that isn't mission critical or time critical, or even to small micros, I will do that. So I like the idea of the not real time stuff going off site and then coming back to you in some sort of other data format, or something that's queryable. Maybe you're offloading it so that you can create some sort of database or ROS access that you can access later.
Yeah.
So we are way over time, but I'll follow up with one question, Kieran. Are you seeing any industrial use cases where what Chris mentioned makes obvious sense, but are there any concrete use cases that you are seeing which requires some offline processing to be offboarded onto some other compute infrastructure?
I mean, I think a lot of it's honestly is just price point sensitivity. So like Johnny's comment is, hey, look at all this great architecture we put in place for Thor. We've solved a lot of this stuff upstream, and at the $3,500 US price point, we're addressing it, right? So then this is sort of the backward looking, which is like, if we move down the Jetson stack, does this become a series of trade-offs, right? So if I'm doing a autonomous vehicle inside a building, right? Then can I lower it, right? So I have multiple robots, pushing to a local, DGX Spark or something like that, doing the processing locally, and then obviously longer term stuff I can push to the cloud. So that's the kind of scenario where, hey, maybe I have a bunch of autonomous little robots. Not every one of them needs a Thor on board. Some of them can just have a much smaller device and then push off some of the processing. And that just brings there's potential to explode the accessibility if you can get something like a vision language action model actually running on the device, and then push some of the compute locally onto the local network before you go to the cloud.
Okay, sounds good. Yeah, let's keep this discussion continuing, find for a few more use cases where it makes sense, and then discuss amongst us as a group. Thanks everyone for joining and for staying beyond the 10 o'clock time. Really appreciate your time, and thanks to the presenters for spending time and sharing your thoughts and insight. We'll reconvene on 14th of October, so I'll see you guys there. And again, Discord is always open. We can have more discussions there as well. All right, thank you, folks. Bye.
Thank you. Thank you. Bye.